Welcome to Apollo Space Camp. I am so excited for this. And you want to know something cool? Alex and I went to outer space last Thursday to get prepped for this. This computer was in outer space, y'all. Isn't that amazing? Oh, wow. So, before we get started, I do have some announcements to make. At Apollo Space Camp, we treat our fellow campmates with respect. We follow our code of conduct and we welcome everybody into the Apollo community, regardless of their race, gender identity, sexual orientation, ability, religion, socioeconomic status, and ethnicity. If you ever feel like the code of conduct is being compromised, please reach out to Fabi from Apollo on Slack or email Fabi at apollographql.com. This event is all about bringing you together to learn, to laugh, share, and explore, to make the most of our time together. And we encourage everyone to fully participate by turning on their video camera, to ask good questions, and engage in Slack. Okay, shoot. Okay, so we were in space and it was a lot of fun, but a lot of weird stuff has been going on since then. And it's fine. Don't worry about it. Hold on. I just need a second. Hold on. Okay. Yeah, I think I got it. Sorry about that. So for those of you joining us on Zoom, please go ahead and ask your questions into the Q&A section. Use the upvote feature to +1 any questions you'd like Khalil to answer, and we'll use your votes to decide what questions to ask. So this is going to be really fun and open and positive, and let's just keep that spirit the whole day. Go out of your way to be positive and to make new friends. Okay, this is so bad. Hey, Alex! Alex, it's happening again. Yeah, I don't know what I did. One of them was showing up. I did that thing you showed me. It was fine, and now there's two of them. I don't know what to do.
Oh no, oh no, oh no. Oh no, this is really bad. What did you do? I told you not to touch that thing.
No.
What? Okay, I'm not going to be able to fix this right now. Why don't you go ahead and introduce the first speaker, and I'll work on this during the first talk.
Okay. All right, so Khalil is a developer advocate at Apollo. He creates courses, books, and articles for aspiring developers on enterprise Node.js, domain-driven design, GraphQL, and writing testable, flexible JavaScript. So fun fact, Khalil used to play drums in a punk band in university. So Khalil's here to teach us about what's new in Apollo Client 3. So please welcome Khalil.
To use Apollo or not to use Apollo? That is the question. Hey, what's going on? This is Dispatch This, using Apollo Client 3 as a state management solution. Just welcome to the talk, honestly. I'm really glad to have you here, and hopefully this is useful for you. Okay, so let's get into it. I'm going to tell you who I am. I'm Khalil Stemmler. I'm a developer advocate at Apollo, and I help developers level up with Apollo, GraphQL, and TypeScript. I'm also very passionate about software design principles, best practices, and I'm working on this book that's about these things. It's essentially the tool I wish I had when I first started out at my first professional job as a software developer. And when I'm not reading, writing, or coding, I'm usually working on music, sometimes with the cowboy hat on. Why? I don't know, just some things are unexplainable and awesome. And so, we could just leave it like that. Speaking of awesome, that's a great segue into the rest of the talk here. So I'm just going to dive into this and let's see what we've got here. So if you're coming into client-side state management in 2020, we have a lot of excellent options right now. We have Redux, React Context, and Apollo Client. How do we decide which one of these to choose? And I think in order to even answer that question, we first need to ask ourselves, what is it that we need from a state management solution exactly? Well, I think the first thing is obvious. We need state, of course. We need somewhere to store some data. And that may include working with remote data that we need to pull in from somewhere. It may include some local state, some stuff that's not in a server, and we may need the ability to combine them and have pieces of remote state and local state work together on the client side. Then we need to be able to update state. And lastly, we have this concept of reactivity. We need some way to notify the pieces of our UI that rely on state that it has been changed and that they should present some new data. So ultimately, I think these are the three pieces that you would expect from a state management solution. And the great thing is, each one of these can get the job done. Yeah, they might have slightly different ways of how they're achieved in each approach, but the high-level goal, the storage and state changes and reactivity, they're all realized here. So, that doesn't really help us a whole lot. We still need to figure out which one we need to use. And, I think it's important to realize that state management is complex. And, if you talk to someone who's used Redux, there's no doubt about that. The state management code can account for around 40 to 60% of a project's code base. To better illustrate where I think all the work goes, let's look at a 5,000-foot view of what I believe to be a generic architecture for most client-side apps. So the first thing we start out with is presentational components. They don't really do a whole lot other than present. And presentation components often have UI logic. Render this if you're logged in, otherwise render this instead. So UI logic is responsible for doing something with data that's coming into a component or creating user events in response to things like button clicks and hover states or key presses. Next, we have our container components. And I know a lot of the industry has moved away from calling these container components. We need something to enable reactivity, something that knows how to get the data from the store, and we need something that knows how to take those user events from the presentational components and connect them to the right place, whether that be a React hook, a service, a Redux thunk, or an action creator. The job of the controller is to act as the glue in the middle that stitches everything together. And this is a talk about the store, right? So how does a store come into play? For example, imagine we have a to-do app and we were working with to-do objects. When I click Edit To-Do, it's possible that I may need to reach inside of the store in order to run some logic that decides what we do next. And I like to call that logic interaction logic. And this is code that's initiated by a user event, contains the preconditions that govern when an operation should be executed. And sometimes that operation that needs to get executed is something like a mutation. When a mutation goes out, then we start getting into all this infrastructural stuff like fetch logic, and that contains things like creating the payload, assigning headers to the request, and specifying the resource location, and state management, and shaping the response into the format that the client needs it to be, and attaching local variables, and merging data, and all this kind of stuff. And finally, we need to connect the new data to the UI, so we need it to flow back through to the presentation there using reactivity. So if you look at this, you'll actually see that this is around half the work. We can kind of see that visually here, right? And at Apollo, we gave a name to this stuff. We call it the data layer. And the data layer holds arguably some of the most challenging tasks that we have to figure out how we're going to address on every client application. And using a bare bones approach like Redux or React Context, you might find that creating the same infrastructure and solving the same problems in every app can be pretty time consuming. So the Apollo client library handles the entire data layer. And that's really cool because now we don't have to worry about this stuff. This is like developer productivity plus in a way. So if you decide to use Apollo Client, you start out with all that challenging data layer stuff already addressed. And here's the rest of the stuff that you still have to do. And these things are pretty important. And these are the things that actually makes your app special. So you can't just pull this off the shelf. I want to say that there's about 3 steps to getting started with Apollo Client at this point. The first step is configuring the cache, and that very well just might be to connect to a GraphQL API. Then we need to query for the data that we need. And then the third thing is we write the mutations to change the data. So this is great. Apollo Client gives us a set of APIs to configure, fetch, and update our client-side state out of the box. We just got to learn the APIs. In Apollo Client 3, we've introduced a bunch of different improvements to each part of the library. So I just want to say the rest of the slides in this talk will be based on a simple to-do app that I've put together on GitHub. It shows how to use the new AC3 features and how to build different versions of a to-do app using local state, remote state, and even the old local resolvers approach. That will still also work. So this is the first thing we normally do. Here's how we might set up the client and the cache. First, we import them. Then we can create the cache. And then we create the client, telling it where to find our graph and giving it an instance of the cache. With this basic setup, we can actually pull in remote state using queries, and we can make changes using mutations. We don't need to do anything special in order to get up and running with this. So one of the first things we could do is pull in a collection of some data. So we do that by asking for the data we want, writing a GraphQL query, and we'll come over here to a container component, and we'll import the query. We'll import the useQuery hook from Apollo Client. We'll pass that into the hook. And we might want to handle some of these async states. And then finally, we can pass the data into the presentational component so that it can render it to the screen. And that might look something like this here. So maybe it's a good idea to understand how this data is normalized and what it looks like in the cache. By default, Apollo Client uses the type name and ID fields to uniquely identify data. So what you're looking at right here is just, it's just a printed version of what the cache looks like internally if we were to fetch all these to-dos. It's relevant to know how the cache works a little bit because it'll affect us when we actually get into writing mutations. So in this next pattern that we'll explore, creating a new item, we can do so by writing a mutation the same way that we wrote a query. There's a small important thing to note here though. See where we're asking for the new to-do? We are including the new item that's going to get created in the mutation response. Because when we do this, the cache is smart enough to identify that something was brought in, and then it will proceed to normalize it and cache it as well. So in a component, what we could do is import the mutation, import the useMutation hook, pass the mutation to a hook, again handle some async states, and then we hook this directly up to the presentational component. And let's see what this looks like. If we're looking at our to-do app and we say add the fourth to-do, it looks like it didn't get added for some reason, right? So now's about the time that I would take off the cowboy hat and put on the debugger hat and go over and look in the cache and see, what is it that's actually stored in here directly. So we can see that we have all of our to-dos in here. We have to-do 1, 2, 3, and interesting. Do you see that? There's to-do 4 right there. It's normalized and it's saved on the cache, but for some reason we're not seeing it render in the UI. And that's kind of weird, right? But you see this right here. This is a very fundamental aspect. It's that it's not being saved in our cached collection of to-dos. These are actually references to to-dos that are stored flat on the cache, and the to-do number 4 is not actually in this array. And you might be asking yourself why, because I was certainly asking myself why. Cache makes no assumptions about how we want to update cached collections. When we did the query to get all to-dos, we created a local copy of some of those to-dos. When the cache sees new data coming in that it hasn't seen before, it will always normalize it. It'll always go through and do that uniqueness thing where it computes that and puts it flat onto the cache, but it won't assume how we want to use that new data to modify our existing cached collections. And this is actually a good thing because mutations and deciding how our existing collections are stored on the cache and how they should change, I think these are all application-specific operations. To Apollo client, all it knows is that we've invoked a mutation. It doesn't know the specific behavior that we'd like to carry out. Only we, the developers, know this. For example, an add to do operation adds to the end of a list. A remove to do splices that object from the array. And an edit to do will update, that to do in place in the array. I think this is a pretty small price to pay for abstracting pretty much the entire data layer. We don't have to think about a lot of things, but we do need to tell Apollo client what behavior we want it to take when we're interacting with these cached collections after our mutations. And the way to do that is using this update function. So if we go back to our mutation, we can pass in an object as an argument, so we can define an update function. What we want to do is add the new to-do to the existing array of to-dos that was saved as a cached collection. So to do that, we'll pull the new to-do from the response, and we can use an API called read query to execute a query to get the existing to-dos from the cache. And then we'll use the opposite, which is write query, to pass in the query that we know we want to set the new value of, the get all to-dos query, and we'll give it the new data, which of course will be an array. And this time it's going to be of all the to-dos that were there before, in addition to this new to-do that we've just added. So let's take a look at that. And voila, there it is. Our to-do is not only saved in the back end on our server, it is also being displayed on our client side and re-rendered here. And to just really drive this home, if we go and we look at the cache again, you could see that that to-do, the fourth one, is also in our cached collection of to-dos. When we're writing this update logic, we generally recommend you use the read query and write query APIs. With these, you can accomplish about 95% of what you'll ever need to do here. But with Apollo Client 3, we also released a new set of advanced cache manipulation APIs, and you can check those out on our lovely docs. So now I would like to move over and talk about local state management, and I said this is my favorite part of the new AC3 release. So, we're phasing out local resolvers. They will still work and they'll still continue to work in AC3, but we have a new approach that we're using. And that new approach is called cache policies. With this, for a particular type and for a particular field within that type, we can modify what the cache returns before reads and before writes to the cache. There's a ton of features packed into this thing, but I'm most excited about the fact that it introduces cleaner patterns for local state management, things like pagination, pipes, and filters, and other very common things that we just need to address when we're building client-side apps. Here's an example of a very common pattern, initializing a default value. So here we have a cache policy, and on any instance of the person type, on the field name, for that field name, when this is being read from the cache, if there's no value already, we'd like to set it with the default value of unknown name. Otherwise, we'll return it with the value that it already has. This is a very basic example, but there's a new feature that cache policies can be combined with that makes local state management a lot more enjoyable to work with. And that feature is called reactive variables. Reactive variables are containers for variables that we would like to enable cache reactivity for. This means that when we change the value of a reactive variable, it'll notify the cache, and it will also trigger a re-render if you're using React. Let's say we wanted to build the entire to-dos app from scratch using local state only. It's a lot easier to do that now. So maybe first we'll define the structure of a to-do type, and then do some more data modeling on that, and then we'll set up what we want the initial value to be. In this case, an array of one to-do seems appropriate. Next, we will create this local variable here called to-dos var using the cache.makeVar function. And we could also pass in the initial value that we wanted to have at the time of creation like this. Now, if we go over to our cache policies, we can hook it up by saying, hey, on this query type, anytime we ask for all to-dos, this to-dos field, we are going to return the current value of the to-dos var reactive variable. And this will give us the most recent value of the to-dos var. And this is also how we connect reactivity up to our cache. So if we go over to another part in our app, we can query for these to-dos. So in Apollo Client, the way to tell the cache that we want to try to resolve certain types of data from the cache and the cache only is to use the @client directive. So now this will only ever attempt to pull to-dos from local state. Then we could do the same thing that we've done before with queries. We pass the query into our useQuery hook and fetch that data and give that data to a component to display. Now to update this, to perform some operations here, instead of doing mutations, we have a lot more say over how we want to update state with our local variables. The truth is, we could do this however we want. We could use simple functions. In this example, we have a delete to-dos function that when composed with our to-dos var reactive variable, it'll give us a function that enables us to delete a to-do from local state using the ID. So first, we can invoke to-dos var, and that will give us all the to-dos. Then we can filter by the ID to create a new list of to-dos without the one we're deleting. And then we could save the to-dos var reactive variable and trigger a re-render by passing it in as an argument. So again, and in case you're sleeping here, it's these cache policies and the reactive variables used together that gives us a much better local state management story. And I think that's pretty cool. So we've just went through a lot of stuff. We learned about the 3 basic pillars of state management solutions. That's to hold state, to make it possible for state to be updated, and to make sure that things are reactive. And we also learned that we call this the data layer, at least at Apollo we do. And this can be pretty complex to build and maintain. So that's why we want to do it for you. We want to give you the tools that enables you to focus on the stuff that actually matters. And if you use Apollo Client, there's 3 things you have to know how to do. And that's configuring the cache. Then we got to fetch data, both local and remote data, using queries. And then we have to mutate data, and we could do that using mutations. And understanding a little bit about how the cache works under the hood is helpful because now we've traded in building this entire architecture for knowing how to use some APIs that handles it for us. I always recommend that if you're just getting started, stick with the basic read query and write query APIs to implement your update logic. And if you're a little bit further along, look into the new cache.modify and cache.vict APIs for how you can get a little bit more fine-grained with your control over the cache. And here's a couple of resources that I found were helpful and you should definitely take a look at. And finally, I just wanted to say thank you and just remind you that you're not alone on this journey. And if you have any questions at any point about Apollo Client, you could always reach out to me or anyone else on the team. We're always happy to chat Apollo with you. And you could find me on Twitter. Even if you just want to hang out, definitely hit me up. Thanks again. Really appreciate it. All right. Hello. Hi. I hope you enjoyed the talk. We have some time to do some Q&A here. And I see there's a couple of questions. So I'm going to get to the first one here. We have a question from Andrea. Andrea says, does the name of the field returned by the mutation have to be the same as the type name so that it gets cached properly? Yeah, so this is an interesting question. I think the answer to that question is yes, because I know that the way that the cache understands the way that the cache understands that, hey, this data coming back is actually something that we know about is it constructs that cache key. There is another way actually now in Apollo to construct your very own cache key. I had it in the earlier version of this presentation, but it was a bit much to show, but there is a new API where you can say, hey, I want to construct the unique key for this cache using, let's say, the email and the email plus the ID instead. So you get to define what uniqueness is. And I think as long as uniqueness can be adequately understood in what is coming back in the way that it's configured, whether it's by default to use the ID plus the type name, as long as that uniqueness can be confirmed, I think that it should know how to cache that item properly. So let's see here. We got several questions. Another one is, what is the difference between cache? What's the difference between cache.read query and cache.write query and using cache.modify? And I will say also cache.modify and cache.evict. So yes, this is a great question as well. It's one that I was also asking myself a little bit. So yes, cache.read query, cache.write query. This was in AC2. This was the way that we would normally retrieve data from the cache and make changes to the cache as well. And this is also the first way that I learned that this works too. And in Apollo Client 3, we now have some more advanced ways to manipulate the cache. We have cache.modify and cache.evict. Cache.modify is this very, it's like a power tool. It's like what we have is we have access to the cache directly. So instead of accessing the cache through queries and writing to the cache with queries, we have the ability to directly say, hey, this particular key in the cache, I would like to change what is stored here, or I would like to inspect what's stored here, then possibly modify what's there. And you could do that with cache.modify. With cache.evict, you could say, I want to clobber whatever is at this particular cache key in the cache. The reason why I suggest using cache.read query and write query if you're just getting started is because the cache.modify and cache.evict, it requires a little bit more understanding of how caching or how the internal structure of how this cache actually works. And if you're just getting started, you might not want to have to spend time learning that right away. But if you're familiar with how cache normalization works and what the structure of the cache looks like, definitely take a peek at those APIs because they're chef's kiss, very powerful. So let's see, what do we got? I'm seeing oh, there's a quick question here from Kirsten. Kirsten says, will we have access to these slides, links and notes? There's a lot of info I want to look back over. Oh, Peggy also already got to that. Yes, we can definitely, we'll definitely put up those slides and all the resources that we kind of talked about. So there's one more here. Local resolvers. Local resolvers allow async operations, but the read policy cannot. Can async be done with cache.makeVar somehow? And that's from Juha. So yeah, well, cache.makeVar is going to give you a variable that has a very limited API, which I think is great. It's a very simple API. It's similar to it's a get and set kind of API to it. So it's whatever you pass in will set the new value, and whatever you whenever you invoke the reactive variable, it will give you a new value. And that's a synchronous thing that you could do. And I think where this question is going is it's asking what kind of or it's asking when we want to change things in an async way, like let's say if we were relying on data from somewhere else, do we have the ability to perform that type of behavior with cache.makeVar? and reactive variables? And yes, I think the answer is yes, because they're just very simple containers to variables. So with that in mind, you kind of have full control to put these reactive variables and functions or classes or however you want. It's as long as when you are saving the variable, you use the API to just pass in the new value as an argument. I think you should be able to enable async operations around doing that. So to answer that very simply, very succinctly, yes, and it has no constraint on how you organize your async code. And I think we might have time for one or two more questions here. So this one is by Andrea as well. One more question on reactive vars. Are they similar to useState from React? And what they actually do is short circuit the cache when reading and writing. Yeah, that's a really interesting way to think about it. Short circuiting the cache. Yeah, because when you change state, you want to enable reactivity, right? And if you just had a regular variable and you set the new value, it might not tell if it's React you're using, it might not tell React, hey, we just changed some data, so we need to re-render. So yes, with reactive variables, they will short circuit the cache, and when you save them, they will trigger that re-render, similar to what you would do with useState. So I think that's an interesting comparison I didn't think about. So I think we are at time for questions. I will be in a breakout room, an Apollo client breakout room with Ben from the Apollo client team. So you should definitely come check that out later on, and we will have some more time to answer questions. And with that said, I'm going to pass it over for our next presentation from Mandi, a talk on federation. And let's check that out. Thank you.
Great presentation, Khalil. That was so awesome. Khalil Stemmler, everybody. All right, so we are super pumped to welcome Mandi Wise as our next speaker. Mandi is the author of Advanced GraphQL with Apollo and React and is the owner of 8-Bit Press Inc. She's going to be teaching us how to build your first federated graph with Apollo Server. So please join us in welcoming Mandi.
Well, hello, everyone. First off, I'd like to start by saying thank you so much to the Apollo team for inviting me to give this talk today. So a bit of my background before we jump in. Again, my name is Mandi, and I've been using GraphQL since early 2017, and I started teaching other people how to use GraphQL shortly after that at a boot camp I used to work at. Fast forward to late spring 2019, I decided I wanted to consolidate everything I had learned about building complex GraphQL APIs over the years into a book. And I ended up getting about a week or two of work done on the book before I woke up one morning, checked Twitter, and saw that Apollo Federation had been launched. After I took a look at its documentation, I promptly decided to throw out all of the content I had just developed on schema stitching and ended up basing the book on Apollo Federation instead. So today, I'm going to show you just how easy it is to get up and running with Apollo Federation. So on that note, I'm just going to flip over to Keynote now. Okay, let's dive in. So the roadmap for my talk today is that I'm going to give you a quick rundown on what Apollo Federation is and why we would want to use it. We're going to do a little bit of a demo refactoring a vanilla Apollo server into one using Apollo Federation, and then we'll finish off with a little recap. So let's start off with answering one of the big questions. What is Apollo Federation? So Apollo Federation is a set of tools that allow us to compose multiple GraphQL schemas declaratively into a single data graph. Now that's a bit of a mouthful, so let's explore what that means a bit more visually. So when using Apollo Federation, we're going to have multiple implementing services, and each of those services are going to have their own GraphQL schema. In front of those services, we'll add a gateway that composes those schemas into a single federated data graph so that clients, perhaps a web client and a mobile app client, can then query a single GraphQL API without needing to worry about the implementation details of the underlying services. So what problems does this solve? Well, one of the most compelling reasons to create a GraphQL API in the first place is that it allows us to expose one data graph, potentially with multiple data sources behind it, like a REST API and a SQL database, and then we can query the data in a way that reflects the relationships between the nodes in the graph. However, as we expose more and more objects and their relationships through various types and fields, it doesn't take long for even a moderately complex app to require a large number of type definitions. In turn, it becomes difficult for multiple people or teams to collaborate on building the API, and what's more, the GraphQL API then becomes a single vulnerable point of failure in the system. The solution would then be to create a distributed GraphQL architecture and break up the schema into multiple smaller services for development purposes, but then recombine each separately managed portion of the schema into a gateway API so that client applications can remain agnostic to these divisions when querying data. Before Apollo Federation, there was an existing solution to do this called schema stitching. However, with schema stitching, there tends to be a necessity to split a schema, sometimes awkwardly based on types, and it also requires a lot of boilerplate code to effectively consolidate the data graph. And that again introduces a single point of possible failure into our application architecture. Apollo Federation addresses these issues by allowing us to split a schema based on separation of concerns rather than by type, and also takes care of the heavy lifting when it comes to combining federated schemas into a single data graph for clients to query. So it really is like having your distributed GraphQL architecture cake and eating it too. Now, before we jump into the demo, we're going to need to wrap our heads around a few key federation concepts. The first is the notion of an entity. An entity is a type that you define canonically in one implementing service and can then reference and extend in other implementing services. Entities are the core building block of a federated graph. They're the things that allow us to split schemas based on separation of concern rather than by types alone. And we're going to create entities using an add key directive in our schema. Once we define an entity, we can then reference it from other services as needed. Other services that reference the entity will only be able to return a representation of that entity from any corresponding resolver. So the gateway is going to have to hand this representation off to the entity's originating service, which means we're going to need to provide what's known as a reference resolver in that originating service to fetch the data for that specific entity. And last but not least, we can even add additional fields to a type originally defined in another service by extending that entity in a referencing service. Okay, so to create a federated data graph, we're going to need to make use of some additional Apollo libraries. So first of all, we're going to need the Apollo Federation library, which allows us to make our services schemas federation ready. We're also going to need the Apollo Gateway library, which is going to help distribute incoming GraphQL API requests to the underlying services. And lastly, we're still going to need Apollo Server because we're going to need an instance of Apollo Server for the Gateway API and each of the implementing services we create. Okay, now that we have some awareness of what Apollo Federation is and why we'd want to use it, let's walk through a quick demo of refactoring a regular Apollo server into a federated data graph with two implementing services. So over in VS Code, I've already set up a basic GraphQL API, and this GraphQL API wraps a REST API that provides us a little bit of data about Apollo astronauts and their various missions. So I hopped over to Chrome. We can see that we have an astronauts endpoint here that will give us an array of astronaut objects containing their names. And we also have a missions endpoint, which gives us some data about the missions, including their designation, a start date, and an end date, as well as an array of crew member IDs, which are references to the astronauts' IDs over here. Now, in GraphQL Playground, I already have this GraphQL server running. So if I query the astronauts by name, I can in fact see that list of astronauts listed here. Okay, so back over in VS Code, we're going to start working through the steps of converting this into a GraphQL API that uses Apollo Federation. So the first thing I'm going to do is stop the server for a moment And I'm going to create a new file to contain all of the code for our astronaut service. And I'm going to start by doing a little copy pasta here. I'm going to grab all of the code from our index.js file and I'm going to paste it over into astronauts.js. Now we're going to need to make a few changes to this file to turn it into an implementing service. So the first thing we're going to need to do is import build federated schema from that Apollo Federation library. The next thing we'll do is we'll set a unique port number for the service because it's going to need to run on a different port from the Gateway API. Then we're going to make a couple changes to our type definitions. So the first is that we want to turn this astronaut into an entity. So to do that, we'll add the @key directive and set its field to ID, which means that whenever another service references an astronaut, as long as that service knows the ID of the astronaut, the gateway is going to be able to help us resolve that field. Next up, we're going to put the extend keyword in front of type query because the query and mutation types originate at the gateway level of our API. So the Apollo documentation says that all implementing services should extend these types with any additional operations. Next, instead of passing the type defs and the resolvers directly into Apollo server, what we're going to do is set a schema property with a value of build federated schema. And into build federated schema, we'll pass an array containing an object which has our type defs and our resolvers in it. And then last but not least, we're going to update this console log message just so that it's obvious that our astronaut service is ready. Now we're going to need to make some changes to our original index.js file to turn that Apollo server into a gateway. So the first thing we're going to do is we can get rid of this fetch import because we won't be making any direct requests to our REST API from this file anymore. We can get rid of the GQL tag import. We can get rid of this constant here. We can also remove the astronaut type definitions and resolvers. But what we're going to need to add is an Apollo gateway. So to do that, we're going to import Apollo gateway from the Apollo gateway package. Then we're going to create a new gateway by instantiating a new Apollo gateway. And into that Apollo gateway, we will pass a service list, which will be an array. And inside that array will be objects representing each of the implementing services that we want to add into our single federated data graph. So our first service will have a name of astronauts and a URL of HTTP localhost 4001. Now, in our Apollo server, we no longer have type definitions or resolvers to pass in, but we do have a gateway, and we're going to set subscriptions to false because at this time, Apollo Gateway does not support subscription operations. We'll give that file a save, and we have one last thing to do before we can start up our GraphQL API again, which is to go into package.json, and we're going to add a script to start that new astronaut service. So we'll use nodemon to start up that astronauts service. Okay, with this code in place, we're ready to start up our GraphQL server again. So we can npm run server, and we can see that our astronaut service has started up now. And if we hop back over to GraphQL Playground and run our query again, we'll see that everything works exactly as it did before. Okay, now that we have our astronaut service up and running, let's go ahead and add a mission service. So back over in VS Code, I'm going to stop our GraphQL API momentarily, and I'm going to create a file to contain the code for our new mission service. And inside of missions.js, I'm going to add some boilerplate for creating our new service. So what we see here will look pretty similar to what we just saw in the astronaut service, except of course we're going to need to run this service on its own unique port. And our mission service is going to be responsible for managing a mission type. So we're going to go ahead and add that type definition in, as well as queries for getting an individual mission or a list of missions. And we're also going to need some resolvers for fetching that data from our REST API. And they're going to look pretty similar to what we saw in the astronaut service. So I'm just going to copy and paste those in again to save a bit of time. So with our basic mission service setup, we can go ahead and make a connection between our astronaut type and our mission type. And we want to do that so we can add that crew field in to our mission type. And from that crew field, return a list of astronaut objects. So we'll add a crew field, which will be a list of astronauts. Now, to use the astronaut type in the service, we're going to need to define it in the service as well. So we will use the extend keyword to define our astronaut type here. And once again, just like we did in the originating service, we're going to need to add a key directive and set fields to the ID of the astronaut. And because we're using the ID as our key, we're going to need to redefine that ID field here. But this time we'll put an @external directive onto it so that Apollo knows that this field was defined over in the originating service. Now our code won't quite work as it is right now because we need to resolve this crew field inside of the mission service. So to resolve this field with Apollo Federation, we only need to return an object, or in our case, a list of objects representing all the crew members that contain a type name property and an ID property to identify that object when the request is forwarded on to the astronaut service. So to do that, I'm going to scroll down to my resolvers here and add a resolver for the mission's crew field. Now in this resolver, we map over that crew array and return a new array of objects which contain a type name property and an ID property. The next piece of the puzzle is to add what's known as a reference resolver to the astronaut service. So if I jump back over to my astronauts.js file, I can go ahead and add that reference resolver for the astronaut type, which is going to be a method called resolve reference, which has the reference object as a parameter. And this resolver is going to actually need to do the work of fetching that data from the astronaut's endpoint, just like we do here below for a single astronaut query. But this time we're going to pull the ID off of that reference object. So before we can start up our GraphQL API again, we're going to need to add our new mission service to the gateway. To do that, we'll add the mission service to the service list, giving it a name of missions. And it will be running on port 4002. And over in package.json, we're going to need a start script for that as well. So we can call that missions, and we'll be using the missions.js file here. Okay, so if we run npm run server now, we'll be able to start up our gateway API as well as our two services. Jumping back over to Chrome, if we go in GraphQL Playground right now and run a missions query, we can see that we get a list of missions with their designation names, and we can even add a crew field now and get that list of the crew members with their names too. So this is looking pretty good, but it would be great if we could traverse the graph in the other direction too, from astronauts to their list of missions. To add a missions field to the astronaut type, we actually don't need to touch any of our existing code in our astronaut service. We can actually extend the astronaut type directly from within the mission service with an additional field containing that list of missions. So if we head back over to VS Code now, in our missions.js file, we can scroll back up to our type definitions here and add a missions field, which will be a list of mission objects. And then once again, we're going to need to resolve this field from within the mission service too. So we'll go ahead and add a resolver for that new missions field on the astronaut type. And we'll have to keep in mind that, again, we only have access to the data about astronauts that exist within the context of the service. In other words, we only have their unique IDs. So due to some funkiness with the mock REST API when it comes to selectively querying resources based on a value inside of an array field, we're going to have to settle for fetching all the mission data and then filtering out the mission objects that don't contain the astronaut's ID in the crew field. But we're dealing with a small amount of data here, so this is okay for our demonstration purposes. I'm also going to make this resolver async so we can use a wait inside this resolver so it's a little clearer what steps we're going through. Okay, so our first step will be to fetch that missions data. And we're going to go ahead and get that missions data from our missions endpoint like we have before. And then we will parse that response. So what we're going to do is return an array from this resolver by mapping over the missions array and returning only the objects that contain the astronaut's ID in the crew field. So to do that, we will return missions filtered. We'll destructure the crew field out here, and we're only going to keep the mission objects where the crew field includes the astronaut's ID. And we're going to need to parse that ID as an integer. Okay, so if we hop back over to GraphQL Playground now, if we go to the astronauts query, we can now get a missions field with the astronauts query, and let's get the missions designation name. Okay, so now we have the astronauts and we can also see what missions they participated in. And that's it. We now have our federated data graph and our gateway API up and running. So, just to recap what we walked through today, we created a federated data graph, 2 implementing services, and an astronaut entity. We referenced the astronaut entity in the mission service, where we used it for the crew field on the mission type. And we even extended the astronaut's entity in the mission service by adding a missions field to it so we can traverse the relationships in this graph in both directions. So if you'd like to see the complete code for this demo, I've posted it over on my GitHub here. And that's all I have for you today. Thanks so much. I'd be happy to take some questions now. Okay, so I've been keeping track of some of the questions that have been coming through Zoom. So the first question that I have here is from John. And the question is, can Gateway work with GraphQL servers that do not use Apollo and might not even be written in JavaScript? So the Apollo Federation documentation actually has a page on this called Third-Party Support for Apollo Federation. And in the documentation, they provide a list of all their known open source GraphQL server libraries that have built-in support for Apollo Federation. So I would encourage you to take a look at that. The next question we have here, is it mandatory to redefine the ID field locally at the service level and even the resolver to pull it from the gateway? Can it be inferred from the @key directive? So that's another great question. It's asked by Andrea. Yes, you have to redefine the ID field locally. The field that you define with the @key directive is actually pretty interesting. So in the example that I gave in my demo, we just use the ID field as the key, but you can actually define multiple fields as a key just by separating them by a space within that field's value. So yeah, definitely take a look at the Apollo documentation if you're interested in doing something like that. So the next question I have here is, if the referenced objects are a list, is it possible to retrieve them from a list endpoint rather than getting each of them separately? And this one was asked by Tom. So thanks for your question, Tom. So I'm not sure if I saw this question come through while I was still giving the demo. So I'm not sure if the remainder of the demo helped answer this question for you, but the key with the referenced objects is that you need to make sure that from the resolver, you're returning an object that contains that type name field as well as the ID. So if it's a list, obviously they're going to need to be in a list format, or if it's a single object, you would just return a single object from the resolver, and you can see an example of that again in the Apollo documentation. So hopefully that helps answer your question. Again, how you end up ultimately resolving those referenced objects in the originating service is going to be up to you. Okay, let's see if we've got any more questions coming in here. If I'm using a data loader, are the astronaut missions requests batched? So this is another great question. So this, there's some different dimensions to this. So under the hood, the Apollo Gateway is doing some work to batch requests that it's sending from one implementing service to another implementing service. However, once that data gets to the implementing service, the same rules still apply with respect to how you're going to need to batch operations to reduce the number of requests you're making to your database or whatever the case might be. So yeah, there's some automagic batching of requests happening under the hood between services, but once that request gets to your service, it's 100% on you to figure out how you're going to deal with that using data loaders. Let's see, what else do we have for questions here? If multiple services have the same exact operation or field name, how would you specify which one to use when composing your query? So I think I might answer this question in a more general sense, because you might be wondering about also redefining types across multiple services. So when Apollo Federation first launched, did some initial experimentation and found that it was a bit tricky to try to have types, objects, interfaces, enums, whatever the case might be, defined in one service and then have the same type used in another service. Initially, it would throw errors, but there's been a ton of work done on these libraries over the last year or so, and there's now support for reusing different types across services, which is amazing. So you can reuse things like objects and interfaces and scalars and unions across services. There's just different rules for how exactly you have to go and redefine those types across the services. So again, I would just encourage you to take a look at the Apollo Federation documentation for those specific rules. Okay, so I'm going to take one more question. I'm going to take the question from John here. Is it possible to run your mission service on its own in its own GraphQL playground? So yes, if you went to localhost 4001 or 4002 to look at the astronauts service or the mission service directly, you could actually see it there in GraphQL playground. Okay, so that's all I'm going to take for questions right now because we're on 11 a.m. here right now. So I am going to hang around in the Slack Federation channel for a little bit to answer some additional questions. If you have any, you can just throw them in there. And now I'm going to hand things back over to our MCs, Eve and Alex.
All right, look, Eve's gone. I'm not too worried about it. I'm pretty sure I can get her back. And I made backup copies of both of us before we went to outer space, just in case something like this were to happen. So all I got to do is make sure I don't delete myself, and come on, I'm not going to delete myself. So in the meantime, we're going to keep this thing going, though. Now's your chance to meet your fellow campmates. In the agenda, you'll see multiple breakout rooms that you can jump between over the course of the next hour. You'll see rooms on Apollo Client led by core engineers, rooms on Apollo Graph Manager, and Federation, among other things. There's also some fun rooms devoted to pets, cooking, and games. We recommend exploring 2 to 4 rooms to learn to meet new people. Click on the agenda to see what's available and join the Zoom link to enter the room. 2 employees will be leading each room and moderating the chat to make sure everybody... to make sure everybody has a good time. Have a fun time. I wonder what this button does.